Have you ever wondered how we can predict future trends based on past data? This is where regression analysis comes in. It's a statistical method that allows us to examine the relationship between one dependent variable and one or more independent variables. Simply put, it helps us understand how changes in the independent variables are associated with changes in the dependent variable. There are various types of regression analysis, from simple linear regression, multiple linear regression, to polynomial regression and logistic regression. Each type is used based on the nature of the data and the relationship between variables. A linear regression is one of the simplest and most commonly used forms of regression analysis. It assumes a linear relationship between the independent variables and the dependent variable, trying to find the best fitting straight line through the data points. In linear regression, we use the equation of a straight line represented as y equals b rho plus b1x plus epsilon. Here, y is the dependent variable, x is the independent variable, bo is the intercept, b1 is the slope of the line, and epsilon is the error term. The goal of linear regression is to find the values of b0 and b1 that minimize the sum of squared differences between the observed and predicted values of y. This process is often done using least squares estimation. Once we've fitted the line, we can interpret the results. The intercept represents the predicted value of y when x is 0, while the slope represents the change in y for a 1-unit change in x. Additionally, we use measures like r-squared to assess the goodness of fit of the model. Linear regression has numerous applications. It's used for predicting sales, analyzing trends, forecasting stock prices, and making data-driven decisions. Consider trying to understand the relationship between the amount of time students spend studying and their exam scores. Regression analysis helps you see if there's a pattern or relationship between study time and exam scores. Take, for example, students' study time plotted on a graph with exam scores. Linear regression helps find the best fitting line through these points, capturing the overall trend in the data. For instance, if the line slopes upward, it suggests that more study time generally leads to higher exam scores. Let's simplify it further with just 2 data points. One student studies for 2 hours and scores 70 on the exam, while another studies for 4 hours and scores 85. Linear regression would draw a straight line between these 2 points. It might predict that if someone studied for 3 hours, they might score around 77.5 on the exam, assuming a linear relationship. So the next time you see a trend and wonder what might happen next, remember regression analysis is the statistical tool that helps us make educated guesses about the future based on past data.